one of the little bit further future, well, I guess the bigger market, bigger impact, it could be done in a healthcare environment where the population in the elderly, the age group is going to explode in the next 20, 30 years. And then we will have a quite a complex problem of providing that kind of physical services. It's not just like not only just lack of labor, also the people need some privacy and wants to also keep their dignity. They don't want to show their inability, for example, and so on. So we like to provide some sort of machinery can help. We quite don't know how the machine is going to look like, but basic capability should be developed before we have a solution. So a lot of people will start having problem in the lower level, the lower leg, lower half body problem, like which will severely give them a problem, like a situation where you can get out of the bed or climb upstairs. All these like a small fraction of the time of the day, you are going to have some physical problem, and they need to get over those problems quickly. For example, I have one of my aunt actually can move around almost every place, no problem. She cannot climb downstairs, which is a very small fraction of time in a day, and you want help in certain particular situation in a very short period of time. And we don't want to have somebody there just to help them whole day long. So it would be great to develop some technology. It can give you some physical help only every time you want, and then that kind of machine can be very specialized, or it can be very generalized. That I'm not really sure what's going to happen, but we should be able to design something that can very safely interact with a human, at the same time also have a higher payload, which is kind of challenging topic. So even in industrial robot, the manufacturing robots are very high payload, but it's not very safe to deal with. So we're developing this core technology where the actuator can be actually safe at the same time. It's also powerful. The basic characteristic of our electric actuator is inherently safer than other machines because it can actually absorb energy very easily. Most machines, even though we're trying to absorb energy, it inherently very stiff, so it can actually cause a lot of impact forces, where our machine can actually just give, but at the same time it can also handle quite a bit of load. So it's going to be much more friendly to physically interact than most of the conventional machines. So the Army actually looking at our actuation technology to use to design like armor suit, like a super suit for soldiers. So the actual project is going on right now. It's going to be pretty challenging to augment the human's capability by adding so many motors and then devices on the body. But maybe some of those technology can be migrate to the elderly care domain, where you might be able to like partially wear some device to help to reduce the gap where some particular patient have a particular problem. I have like one knee problem, for example, and then some robotic suit can just like augment to bridge the gap where the specific problem caused huge mobility issue. We envision that Cheetah 3 will be able to navigate in a power plant kind of environment where some radiation present within about 2-3 years. So human should be able to control in a high level, like go forward and then look at the map and then find this place, for example, and open door. All these details should be done by human, but we should be able to start using this robot to investigate those kind of dangerous spaces. And probably another 5 to 10 years, hopefully we can actually do much more real physical work. Like there are many power plant has to be disassembled actually, and then so that they can take it apart. They need to basically literally just the cut pieces and then bring it out. That kind of capability we hopefully can achieve about 10 years, and hopefully in 15 years, 20 years we can send this machine in a real building fire.